Did anyone try to perform those assignments? Like three assignments I've given. No? Okay, let's see next object, which is deployment. So deployment object. In the deployment object, it is just like a replica set, but it has some more features than replica set as a deployment object. Let's see one of it. I'll be starting the environment again. Killer Coda. Let's create one file as deployment hyphen example. Press an I for insert. API version. Apps slash v1. Kind is deployment. Metadata is, let's give the name to the deployment object. So the name for the deployment object, let's take it is Nginx deployment. Specifications spec. So let's suppose we are creating replicas here in the specs. So we are creating three replicas. Then comes the selector. Selector support. In the selector support, we'll try to match the label. Okay, match labels. Inside the labels, app. App. What kind of app? Suppose Nginx. Then we'll go to template. In the template, we'll again see the metadata. Inside the metadata, we'll define the pod inside the deployment. So now this time the name of the pod. Earlier it was the name of the deployment. Now name of the pod. So name, suppose it is, let's take nginx-pod. Labels. In the labels, we called earlier was app, and we are labeling this pod in the nginx deployment as app and nginx. And then comes the specification for the containers. Specifications for containers inside the pod. So name of the container, name, nginx container, suppose name is nginx container, image, docker. Docker.io slash library slash nginx and the image latest. Escape colon wq exit. Let's create the deployment. So kubectl create -f, that means the file name. The file name is deployment-example.yaml. So deployment is created. Now if you run kubectl get deployments, okay, 3 are up to date, 2 are available, 3 out of 3 are available and ready. Okay. Kubectl get replica set. So inside the deployment, this is the replica set now. Okay. And inside the replica set, there are pods and the containers. Okay. If you see the pods, so kubectl get pods. Okay. These are the pods. So how is the hierarchy going on? Like earlier, we have learned about pod, then replica set, then deployment now. So under pod, there were containers, grouping of containers. Under replica set, grouping of pods. And under deployment, it is grouping of replica sets. Okay. So this is our deployment. This is our replica set. And this is pods. If you do kubectl get all, so you will get everything here. The pods basically, the deployment and the replica set. Let's copy this. To check, you can run commands to check. What commands you can run? These. Can get the history from here. Okay. To apply the YAML, run this, and to check the deployments, run this. Now, let's talk about the deployment strategies in the deployment. What do we get using deployment object? So we'll talk about deployment strategies. So in the deployment strategies, we have strategies like recreate strategy. Oh, now these can be asked in interviews. Obviously, these will be asked in the interviews only. Okay. What do you mean by deployment? What do you mean by recreate? Okay. What do you mean by rolling update? So these are strategies inside the deployment. So any kind of deployment you are performing, whether you are performing in Azure DevOps CI/CD pipeline or okay, there also these are the deployment strategies which are followed, like recreate, rolling update, okay, canary deployments. These are asked in the interviews. Okay, so let's talk about these strategies only. So first is the recreate strategy. Recreate. So deployment object is famous for their strategies or its strategy. Okay. So what does the recreate strategy says? So recreate strategy says that to upgrade to upgrade to upgrade delete all the replicas of the application instances. Means if you want to upgrade the current deployment, you have to delete all the replicas of the application instances. Whatever the application instances are running as of now means the pods, you have to delete them all. Okay, that is a recreate strategy. And then create the new ones. And then create the new ones. This is recreate strategy. Okay. What are the drawbacks? What are the drawbacks here? So drawbacks are suffers application downtime. Suffers from application downtime. You have to take the downtime for this. Okay. Second is, this is not the default deployment strategy. So not the default deployment strategy. Second type of strategy after this came in was rolling update. Rolling update strategy. What does rolling update strategy says? So rolling update strategy says bring up the newer version and take down the older version one by one. Means to upgrade, bring up the newer versions and take down the older versions. Older versions one by one. Means after the new one is deployed, then you can take down the old ones one by one. Okay. What is the advantages here? Now those were the drawbacks actually. So advantages now. So to overcome that recreate strategy only, they bring up this rolling update strategy. Okay. So what are the advantages here? So advantages are application never goes down. What else? Default. It's a default deployment strategy. So now question comes, what is the default deployment strategy? So rolling update is the default deployment strategy. Okay. Looks like a very simple question, but many of it cannot answer that. Okay. Because they do not study. Okay. So even if you know Kubernetes, that means like you should have to know theory as well, because they will be asking questions over theory only. Okay. So default deployment strategy. I've seen many people in like my organization as well. People know everything. They run queries, they run commands. But if you will ask the questions to them, they do not know. Okay. So that is the difference come in interviews then if you ask them. Okay. So they know everything, but they are not able to answer the questions, simple questions. So please go through this. When a new deployment is created, so when a new deployment is created, it first creates a replica set. It first creates a replica set. automatically, which in turn creates the pod, which in turn creates the pod, creates the pod. So after creating the replica set, once you create the deployment, after creating the replica set, it creates the pods. When you upgrade the application, the deployment object creates new replica set and pods. So when you upgrade the application, the deployment object creates new replica set and pods. At the same time, it takes down the pods, it takes down the pods in old replica, in old replica set using rolling update strategy, using rolling update strategy. Command you will use like kubectl get replica sets or kubectl get rs. Now we'll talk about rollouts, okay, and versioning, how we can perform versioning here. So rollouts and versioning. So when we talk about rollout, when we create a deployment, it triggers a rollout. When we create a deployment, it creates, that means we are creating a rollout. And that is known as rollout when we create a new deployment. It creates or it triggers a rollout. It triggers a rollout. New rollout creates new deployment revision. New rollout creates new deployment revision. Now, whenever container version is updated, container version is updated, a new rollout is triggered. Means a new deployment. And a new deployment revision is created. which helps to keep track, which helps to keep track, and if required can be rolled back to previous version. Now what we are talking about here, that whenever we have a deployment with us, and now we are creating a new deployment. So whenever we creating a new deployment with new image or new version, so it triggers a rollout, and new rollout creates a new deployment revision. Like earlier deployment was revision 1, so suppose this is revision 2. Now, whenever container version is updates, a new rollout is triggered and a new deployment revision is created. So every time we are creating the deployment, every time a new revision is created. So what is by this rollout, what is happening? By this revision, what is happening? It is maintaining a version control. Okay. So this deployment object is also maintaining the version control basically. So now suppose we deployed anything as revision 2 and say client does not wants it. Okay. So without making changes in the code or anything, just go back and like perform the rollout command. Okay. Or rollback command. Sorry. Perform a rollback. So it will be rolled back to the previous version or the version which you want. So how do we check? We will be checking like kubectl rollout status, kubectl rollout status, and kubectl rollout history. Kubectl rollout history. So history will show you the revisions. Okay. So kubectl rollout history. Now, if you want to perform a rollback, so to roll back to the previous revision, what you can do, destroy the pods in the new replica set and bring older ones up. Destroy the pods in the old replica set and bring the older ones. Older ones up. So what is the command? Like kubectl rollout undo.
Abhishek, it is destroy the new replica set or older asset.
No,
Just
no, no, no,
confusion.
no. This we are talking about rollback. So basically, you are my client. Already
Mhm.
we have deployed revision one of the application. Now you said to make some changes, and those changes are made in the code, and according to that, a new image has been created. Okay. Suppose in the
Okay.
revision one, we deployed Nginx Alpine image.
Mhm.
In the second revision, I have deployed Nginx latest image. But as you are my client, you said, no, 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 this revision does not works. Okay. We don't like the features or anything. So what I can do, I can perform an undo, kubectl rollout undo. That means whatever the new version is that, okay, whatever I have deployed the new revision, it will destroy the replica set and the pods, and it will bring up the older ones, like whatever my last revision was. So last revision, suppose last revision deployment was Alpine with the Alpine image. So it will bring up that one and destroy the new one which we have done in the revision 2. So that is rollout undo. Okay. So in that case, we do not have to make changes code. Nowhere we have to make changes. We just simply have to run the command. That's it. Okay. To undo the deployment, whatever we are doing. After doing the deployment, whatever the results, maybe that like product owner does not like that. So we can undo the deployment. You understand?
Yes, yes.
Okay. So kubectl rollout undo. What you have to undo? Suppose deployment and the name of the deployment. Suppose name of the deployment is Nginx deployment. So please undo the revision of this deployment, Nginx deployment. So please make it or roll it back to revision 1. Also, also, you can name the revision to which you want to undo. So if you want to mention the revision to which you want to roll back, you can also provide that revision. So it will be like the same command, whatever is here, same command. This will be the command here. kubectl rollout undo, but after undo, I will mark it as undo to which. So hyphen hyphen 2. Suppose I want to roll it back to revision number 3. So hyphen revision and equals 3. I want to roll it back to revision number 3 and then the deployment and the deployment name. This is how. So this is the command using which you can roll back the deployments. So we'll see this. Okay. Let's check two more services first and then we'll see. So now let us talk about annotations. After this, we'll practice this. Okay. So annotations. So what are annotations basically? So annotations provide brief description of why a specific revision was created. So it will describe the revision basically. So provide brief description of why a specific revision was created. Means you will mention the description why we have created, what is changed in the new revision. So you will mention that change. Okay, that earlier we have this, now we have this. Okay, so you are giving a description over here. So where you will be giving the description? So example like you will mention under metadata. Under metadata, you will mention annotations. Annotations. And under annotations, suppose I want to describe. So suppose kubernetes.io slash change and cause. What is the cause? Okay, change cause. So whatever the change cause is there, you will mention over there. Okay, in place of change cause. Okay, and first rollout. Okay, suppose this is. Then comes the services. We'll talk about services now. So what does the service do in Kubernetes? So it enables the communication between various components. Service object. It is also an object. Okay. So sir, I'll write here service object. Object. So service enables the communication. Why we create a service in Kubernetes? Service enables the communication between various components within and outside, within and outside the cluster. Outside the cluster. So whether the service is created inside the cluster or outside the cluster, service object is used for that. Okay. So example, like in the pod one, we are running the front end. And front end, we are running what image? We are running Nginx. Then in the pod 2, in the pod 2, here we are running backend. In the pod 3, some external data source we are running. So now from the node, now from the node means inside the cluster. We can access the pod. Means if you go inside the node, you will be able to access the pod. You can curl the command and you can see the web page of Nginx server. Okay. So now from the node, we can access the pod web page. Using what? Using curl command. Using curl command or browser. From outside, we need to access the pod through the node. We have to access the pod. If you are accessing from outside, outside means over the internet. So from outside, that means over the internet. Over the internet. We have to access the pod through the node. Through the node. That means we have to use node IP. That is, we have to use node IP. Node IP helps in external communication. For this, we have to use Kubernetes service. Now, what are the service types? Service types. Cluster IP. Cluster IP service. Cluster IP service. Or just write cluster IP. Okay. So what does the cluster IP service do? Creates virtual IP. Creates virtual IP inside the cluster to enable the communication between different servers. Servers means here I am talking about node. Inside the cluster I am talking about. Okay. So suppose we are running example here. I'll give you example. We are running set of pods. We are running set of pods. Okay. And in this, we have what? We have front end, suppose. Okay. And in the front end, we are running, suppose, web server. Okay. And the service we have to use to group backend pods. So in the front end, you are running web server. In the back end, you are in the backend pods. Okay. You are running, suppose, any backend service. Okay. Database or anything. So how will you communicate? So use cluster IP here. Inside the cluster communication, for communication inside the cluster. Another example, we are running set of pods in the backend. Where we are running? Backend. So now we need Kubernetes service to group. Suppose we are running Redis. Okay. Redis pods. What is Redis? Everyone know what is Redis? It is a caching service basically. Okay. So we are running Redis pods here. So how will you, what we will use? Use cluster I. Since again, this is a service we are running inside the cluster. Okay. And then set of pods for Redis. So again, it's a type of a connection here. Okay. Means set of pods were running for front end, which contains the web server. Set of pods were running for the back end, okay, which contains maybe some database. But how they are communicated? Using cluster IP service. Now, set of pods running for the back end, okay, but how they are connected to Redis service? Through cluster IP. And then at last, you can see set of pods running for Redis. So what type of communication is having here, like from here to here? So the communication we have from here to here is using cluster IP. Communication inside the cluster using cluster IP. Okay. Now let's see one example. Suppose we create a service. So vi service definition dot YAML. Press an I, API version v1. Kind is service. Kind service. Metadata name backend, suppose. Okay. Spec type. What type? Suppose this is cluster IP type of service. Okay. What ports it will run on? It is a web server basically. So ports it will run on is port 80. Okay. So ports port 80. Selector, suppose selector is an app and that name of app is my app. And what type of app it is? It is a front end. Okay. Type is front end. Escape colon WQ exit. Let's create the service. kubectl create -f service definition dot YAML. Created kubectl get service. You can see backend cluster IP. It is running on 80. Okay. And you can see cluster IP is created basically. Now this cluster IP will be involved in the communication between the pods. So if you do kubectl get service, you will get it. Okay. The service can be accessed. Let me copy this. So you will create it. To create, there is the command, and to check check. So you will get it like this after checking. So this is the service. Now you can do like curl, HTTP and IP like this. So whatever the service here like this one. So like curl, HTTP. It will not connect because it is not connected to any front end server. So what it says couldn't connect to the server, the front end server basically. Okay. So since only you created this service, that's it. Okay. You didn't mapped this service to any of the front end, web app or anything. That's why. Okay. So this is cluster IP type of service. Then there is another one, node port service. So second one is node port. Node port. So listens to a port on the node and forward the request to the pod running on the node. Listens to a port on the node and forwards the request to the pod running the node. Means node port type of service if I will create. So instead of listening on the pod level, it will listen on the node level. And using the node only, we can expose our pod to the for the out communication, like outbound communication. Okay. To access the internal pod accessible on a port on the node. So it can be used to access internal pod accessible on a port on a port on the node. So now this time using node port, we can use node IP, okay, and we can check the service running on the pod using the node IP. Okay, from outside, not from inside the cluster, from outside. So how do you check this? Like port on the pod. What it does, it is called the target port. The port on the pod is known as target port, where the application is running. So actual application is running here. And port on the service, this is known as port. Okay. So target port is the one which is running on the pod, and service port is the one which is running as a service. So service has its own IP address, has its own IP address, which is known as cluster IP of the service. And then comes port on the node. So these three types of ports are there. Okay. Node. So this type of port is called as node port. Node port. What it is used for? Used to access server externally. Used to access server externally from the internet. Okay. Port range is port range for node port is from 30,000 to 32,767. So this is the node port range. Okay, question can be asked. What is the port range for node port type of service? Okay, so the node port range is starting from 30,000 to 32,767. Any port between this you can allocate, or it will be allocated for the node port. Now, next class we'll see how to create a node port service. Okay.